Today I'm going to talk about some of the equations that parametric equations turn into, the rectangular equations. So these parametric functions that we're going to talk about are going to have sine and cosine of theta, and they're going to produce something called conic sections. A conic section is a particular type of graph that would be produced by slicing a cone. If you think about a cone shaped, if you sliced a cone straight across and looked at the edge that you just sliced off, it would be a circle. If you sliced a cone in a diagonal direction, the surface that you would be looking at would be an oval or an ellipse. If you sliced it straight up and down, you would produce a parabola shape. Or if you put two cones on top of each other, there's a third type of conic section called a hyperbola. We're going to be looking at 3 out of the 4 conic sections. The first one being a parabola. And a parabola is a y equals ax squared plus bx plus c equation that would be open up or open down. This is if A is positive, or A is positive, or if A is negative. And you've studied those before. You can also have x equals ay squared plus by plus c. And this type of a parabola would open to the right. It would be shaped like a C if A is positive, and it would be shaped like a backwards C if A is negative. And these are not functions. You could produce these types of graphs, though, if you were to write some parametric equations. The 2 important ones I'm going to look at or concentrate on in this video, though, are the circle. And a circle's equation is x minus h squared plus y minus k squared equals r squared. H and k are the coordinates of the center, and r is the radius. For example, if you have something like x minus 1 squared plus y plus 2 squared equals 16, the center is going to be at 1 comma negative 2. It's the opposite of these two numbers, and the radius is the square root of 16, which is 4. And we looked at some parametric equations today in class that produced circles, and sometimes the circles had the center at the origin, and sometimes they were not at the origin, so h and k would have values other than 0. The third type of conic section is an ellipse. And we also graphed some ellipses today in class with our parametric equations. Our standard form of an ellipse goes like this: x minus h squared, just like the circle you start out with. But then you have to divide it by some number, and we call it a squared, plus y minus k squared all over b squared is equal to 1. And if you remember when we were eliminating the parameter, we had a sine squared plus cosine squared equals 1, and that's how we came up with the equation of the ellipse. Now this ellipse has a center at hk, just like the circle did. And from hk, you're going to go a units right and left of the center, and b units up and down from the center. That would be the edges of the ellipse. So A units left and right of the center, and B units up and down from the center. For example, here's an equation of an ellipse in standard form. You could have something like x minus 2 squared all over 16 plus y plus 1 squared all over 9 equals 1. So if you had this equation, you would recognize this as the standard equation of ellipse, or standard form of an ellipse. The center is the opposite of these two numbers in parentheses, which is 2, negative 1. And the top edge, or the right and left edges, are 4 units away, left and right. From the center, and 3 units up and down from the center. So now what I'm going to do is I'm just going to grab a piece of graph paper right here, and I'm going to graph this ellipse. So this ellipse again had a center of 2, negative 1. So you go over 2, down 1. Here's the center of the ellipse. And then it's 4 units left and right, the square root of 16, which was the denominator. So you go 1, 2, 3, 4 units left, 1, 2, 3, 4 units to the right. And then you go 3 units up and down, 1, 2, 3 units up, and 1, 2, 3 units down. And that's the edge of the ellipse right here. So here's the graph of the ellipse that has this equation. The only difference between parametric and rectangular equations is that you don't know what the orientation is of the particle motion. You don't know whether it's going clockwise or counterclockwise. So the next thing I'm going to do is I'm going to create some conic. I'm going to create a conic section from parametric equations. And you had a look at this today in class in one of your exercises, but I'll just have it for your notes. So this is conic section, a conic section, using parametric equations. Or parametric functions. So for example, you might get something like this. X equals 1 plus 2 sine of theta. Y is equal to negative 4 plus 3 cosine of theta. So there are parametric equations. And what we're going to do is we can create our theta xy chart. And we only have to step up by pi over 2 because we have a cosine of 1 theta. So theta, x, and y. So theta is 0, pi over 2, pi, 3 pi over 2, and 2 pi. That should give us enough information to get the orientation. And so now when we plug in theta equals 0, we have 1 plus 0, which is 1, and y is negative 4 plus 3 times 1, which is negative 1. When theta equals pi over 2, sine of pi over 2 is 1, and 1 and 2 is 3. Cosine of pi over 2 is 0, so we have negative 4 plus 0. When you plug in pi, sine of pi is 0, so you have 1 again. And the cosine of pi is equal to negative 1, so this would be negative 4 minus 3, which is negative 7. Sine of 3 pi over 2 is negative 1, and 1 minus 2 is equal to negative 1. And then cosine of 3 pi over 2 is 0, so negative 4 plus 0 is negative 4. And then the 2 pi has the same coordinates as 0, so that goes back to 1, negative 1. So I'm going to graph this right now on my little graph paper here. So we start out with, hopefully you've written this down so I can just here. So we start with 1, -1, 3, -4, 1, -7, -1, -4, and 1, 1. So it looks like it goes around in this direction, which is clockwise. And right here we started up with theta equals 0. Over here we had theta equals pi over 2. Down at the bottom, theta equals pi. And over here we had theta is equal to 3 pi over 2. So we have an ellipse. It looks like the ellipse's center is at 1, -4. And it goes left and right 2 and up and down 3. So hopefully we'll come up with an equation that matches that. So if we eliminate the parameter on this, we're going to subtract 1 first of all. X minus 1 equals 2 sine of theta, because we have to solve this for the sine of theta. So we're going to bring this one down here and then divide by 2. So x minus 1 divided by 2 is equal to the sine of theta. Down here with the y's, you're going to add 4 to both sides. Y plus 4 equals cosine of theta, and you're going to divide both sides by 3 to get rid of that 3. So because sine squared plus cosine squared is equal to 1, you're going to square this and set it equal to 1. So right here we have x minus 1 squared all over 2 squared, which is 4, plus y plus 4 squared all over 3 squared, which is 9, is equal to 1. And so what this tells us is this is an ellipse. The center is at the opposite of these two numbers, which is 1, -4. And left and right from the center you're going 2, and up and down from the center you're going 3. And let's see if that's what we had. Looks like our center is at 1, -4. Left and right you go 2. Oops, you can see this. Here's our center. Left and right 2, up and down 3. So here's the rectangular form. And here is the parametric form of the ellipse that we just graphed. Let's take a look at this in the graphing calculator. So our equations were again 1 plus 2 sine of theta and -4 plus 3 cosine of theta. You want to look at the window? We go from 0 to, if it's not already 2 pi, you can just do 2 pi. And when you're doing trig functions, if you want a nice smooth curve, you can step up. The t-step you can do like pi, I think pi over 24 is the default. And because our x values, the leftmost one was -1, so I'll just go back to -2. The rightmost one was 3. I think I'll go over to 4. And our y min, I'll go down to -8, and I'll go up to 1. So there's our ellipse. It looks like it's longer than it is tall just because of the window that I chose. Maybe I should go up a little bit higher on the y-axis. Would that make it? Let's see. That make it? No, that would make it go the other way. Sorry. 1. I think we need to go out to like 8. There we go. That looks a little bit better. So it's a little bit taller than it is wide. And if you traced around this, t equals 0, that's our theta value. Our theta value started at 1, -1. And if you traced with your right-hand arrow button, you can see that it's moving in a clockwise direction. And then it should stop right there. You can't go any further than what you've set your Tmax at. Then if you wanted to look at the table of values, you can table set start at 0. You can move up by pi over 2. And then when you look at your table of values, you should get the same x and y values. This is pi over 2, pi, 3 pi over 2, and 2 pi. Then you'll get that same xy table that you produced over here. Now I just wanted to show you one thing. If you wanted to, instead of going clockwise, if you wanted to go in a counterclockwise direction, you can do one simple switch. if you switch the sine and cosine function, so if you called this top one a cosine and this bottom one a sine function, you'd look at the same graph. That's the same ellipse, and you can see that with the table of values. They're in a little bit different order, though, because when you trace this value, when theta equals 0, the starting point is over here. So here's theta equals 0 instead of our other one, which started at the top. And then if you trace this to the right, you can see that this is going in the opposite direction. This is going in a counterclockwise direction. And right here, when the theta value, this is pi over 2. When theta is pi over 2, you're up here. And then keep going, and when theta equals pi, which is 3.14, theta equals pi, you're over here on this side. So it's going in a different direction. It's got a different starting point and a different ending point. So that's just one way of switching the orientation. It's just switching the sine and cosine functions. All right. On my original video, I had a little bit more to share with you, but I don't think I need to put anything more on this video. I think you have everything you need about parametric equations. So I'll see you tomorrow. Have a nice night.